Welcome to my presentation, Mortality in Germany, a mathematical assessment. My name is Jörg Rockstroh. You will find my contact details below and you can contact me on LinkedIn for any questions, comments or remarks you have, but please do it respectfully. I made this presentation because a long-lasting friend of mine sent me his presentation about excess mortality in Germany in the year 21. And I thought, okay, I will have a look at the data and see if there is an excess mortality rate in Germany in the year 21. Therefore, we have two hypotheses. One, there is one, and two, there's none. And the presentation will go through and see if hypothesis 1 is true or hypothesis 2 is true. We both use the same data provided by the Federal Statistical Office of Germany, going forward called the Statis. Now, before we going into the presentation, let's define what is excess mortality. There's different definition on Wikipedia and on the internet. Unfortunately, the German and the English one are a little bit different. However, it is important to say that excess mortality is defined as more death than expected, means it's more than the trend line or prediction would suggest, and that can be through epidemics, pandemics, influenza, war. Now let's go into the presentation with the basis of the hypothesis. Let's see the basis of the hypothesis. First of all, I would like to change the word excess mortality to death because that's what we try to prove. In that case, the author went with the data for calendar week 1 till 48, was calculating the average for the year 2016 to 19 and compared the number to 21. Let's have a look at the figures of deaths occurred in the period. And I went back to 2011. And as you can see, 2011 was 850,000 and now 21 it's almost over, or it's over a million. So you can see there is over the years quite an increase. And I use then the full calendar year, so I have one specific time period compared to a next time period. And as you can see, the percentage increase went already down. Now I use the same method as the Statis because they're using the last 4 years and calculating the average, the median average, compared to the current year. And you can see that number went down again to 5.26. However, I don't know what that number means. For that reason, I was building a table for all the years. So from 2011 to 14 until 2017, 2020, and compared the death with the average. And as you can see, in the year 2015, we have in the period under review the highest increase with 6.22. We also have a year with only 0.94 and the last 2 years with 5.48 and 5.26. However, I don't know is there an excess death or not, because you can see that number will never be minus, it will always a plus, the percentage, because we're using an average in an increasing death rate. Now let's look in detail, because I think that's important to see how did the death change over the years. And I want to point out that the year 2015 had the highest increase in death from one year to the next with the highest percentage. However, it's difficult to look at just data, so I put it on a graph. And I used then a trend line to see where is the function going. So it means where are the deaths going based on that 11 years. And as you can see, the depth is really a little bit over, a little bit under, looks like quite on the trend line. And I even zoom into the trend line, and that's what you can usually do sometimes. You need to always be careful about the y-axis. As you can see now, it's even more pronounced that it's going up. And as you can see, there is a function for the trend line, and I use this function. I use this function to calculate the expected value for the year 21. So let's take the values in, and in that case is x11, put it in the formula, we come to a value of 985,621 deaths. So that's the deaths expected for the year 21. We already know the number for the year 2021, and our trend line is out by 17,554 deaths. What is a really slim percentage on the total number? As you can see, I plotted then the data onto the graph. And as you can see as well, the trend line functionality, the trend line function changed and has now a higher R value. R value is important for trend lines. It should be over 0.8. Everything over 0.9 is really good. If you would have a value of 1, you could calculate exactly the expected value in the future. What is quite interesting, because if you have 100% data, you can calculate the future 100%. Now, we're using now the new function, doing the same calculation, setting all the values into the formula. We're getting now 995,576 deaths. Using that again against the real figure. And our discrepant difference is only 7,599 deaths. As mentioned, the R value went up. Therefore, our prediction is more accurate. That still doesn't give me if there's excess death or not, because one big value for me is missing, and that's the population. Again, the status is providing us some nice figures with the population, and I put the graph for the death against the graph of the population. It looks like both are going up. However, I don't know if there's correlation or not. Therefore, I want to know how many people die every year out of the population. Because the census was done in May 2011, I moved the population 1 year down. So I used the May 2011 population for the year 2012. And as I said, the population went up. There is one thing I need to mention, and that is by the status in 2016 and 7 through the unforeseen circumstances, the figures are not really accurate and there's limitations. However, the death rate or the death figures and the population figures are given by the same department. So I'm only using the figures available today. I also want to mention that at the moment, nobody knows how many people are living in Germany, because the last census was in 2011 and everything is only calculated going forwards for the following years. Here we see now the population with the death occurred in that year and the percentage. And as we can see, it's always over 1%. And we can also see that in the last 2 years, 1.185 and 1.206% of the total population died. You could say, oh, there's more people now dying from the population. However, I don't know what that means. So we need to look a little bit more in detail into the population figures and the death and where those deaths are occurring. And as I said, this start is providing figures and the total deaths per age group. So we can see every year how many people die in which age group. The only thing what I added to this table is the difference in numbers and the difference in percentage. And we can also see as well in the age group 75 till 80, from 2018 onwards, every year less people died in that age group. In the year 2019, it was almost every age group had less death than the year before. In 2020, a few age groups had less death, and some increase. In 21 we see in age group there's more deaths occurring. However, quite slim numbers. For example, in 30-35 there's 82 more people died in that age group. And as you can see, they're all sitting around the 2,600. Now, unfortunately, the status gives us the population in the following age groups. And the deaths age group are different. Therefore, I group them that I can compare the death per age group to the population in that age group, and have 4 groups: 0 till 40, 40 till 60, 60 till 80, and over 80. And that's with the figures given by the status gives you the following table. That is the death per group from 2011 to 21. And as we can see in the group 0 till 40, the numbers is around 14,000. Even 21 and 2020 are under the number from 2017, also under the number of 2015. In group 40 till 60, it looks like the deaths are going down, starting from 80,000 down to 75,000, with some 72,000 numbers between. Group 60 till 80, if you look at the figures, it stays between 316,000 and 332,000. And group over 80, from 440,000 now up to 600,000. That's quite interesting. Now I want to know, what is that percentage on total death per age group? And I made the same calculation with the numbers given. And as you can see, group 0 to 40, only 1.42% of total death occurring in that age group. The 40 to 60 is only 7.49, and as you can see, the numbers already as well, even if the numbers stay the same, the percentage-wise on the total deaths are going down. The same is for the age group 60 till 80. So they made 37% in the year 21 of all deaths occurred in that age group, and it went down to 32.81 in the year 21. However, the group over 80 went up from 51.72% almost to 60%. So from your death, total death, 60% are people over 80, and only 1.42% are from 0 till 40. And therefore, I made it a red line that you can see how those deaths really are distributed. Again, the group over 80 is contributing 60% almost to the total death. And it looks like it is increasing in the period under review. Here I put that on the graph. Not as expected. Everything looks like stable, but group over 80 is going up. Just some fun calculation where I used the death from 2011 compared to the death in 21. And can you see there's almost 160,000 more deaths in the age group over 80. Again, I want to know, compared to the population size, is there increase or not? What is happening? Because yes, we see there's a lot of more deaths in that coming from that age group, but if the population goes up in that age group, means it is more deaths to be expected in that age group. And then I graphed the population of all 4 age groups. As you can see, 0 to 40 went up, 40 to 60 went down quite a bit by 1.6 million. Group 60 till 80 went up by 1 million, and age group over 80 went from 4.3 million to almost 6 million. And now we're getting the death from each age group in. We said that the death in the age group 0 to 40 is quite stable, age group 60 till 80 quite stable, age group 40-60 went down as expected because there's less people in that age group, and death went up in age group over 80 as expected because the population at age group is going up. However, even that doesn't give me the information if there is an excess mortality or not. So for that reason, let's look in the age group over 80 because 60% of all deaths occurring in that age group. And it's important to know in Germany life expectancy currently for male is 78.6 years and for females 83.4 years, combined of 81 years. I'm aware that there's more females in the age group over 80, but for calculation reasons I took an average of 81. And now we're looking at the population again with the death rate in that age group, or not death rate, sorry, the accumulated deaths happening in that age group. And then we can calculate the percentage. So how many people die each year out of that age group? And as I said, life expectancy is 81, so you would expect that people reaching that age have a really high chance to die because they're over the expected life expectancy. And as we can see, the highest figure was in the year 2015 with 11%, and the lowest figures in the year 2019 with 9.9%. It is even 9.98, so if you would round up, it would be 10%. And as we can see in the year 20 and 21, it's quite low numbers. So only 10.2 and 10.1% of that population died. And put that all together on a graph. That is blue is the percentage of that age group dying, and orange is the death in that age group. As we said, went from 440,000 to almost 600,000 in the period under review. Now, if I have a population as Germany, which is aging, means it's an increasing population in the over 80, what is over the life expectancy. I have a constant over the last 10 years of 10.5% of people in that age group are dying. It's not even the percentage increasing. It's a 10.5% of that age group population is dying each year. That means I have increasing death and a total increasing death. There's nothing unexpected. If I know for 2022 how many people are in that age group, and I take 10 till 10.5 and I calculate how many people I expect to die, I can with quite certainty calculate how many deaths I will have in that age group based on the previous data. Now, coming to the conclusion. Hypothesis 1 was there's an excess mortality rate in Germany in the year 21. Hypothesis 2, there's no excess mortality in Germany in the year 21. And then coming back to the definition, it means unexpected death. Now, as provided and shown, it was clearly possible to calculate how many deaths I would expect in the next year. Therefore, I will need to say that hypothesis 1 I was not able to prove. However, I was able to prove hypothesis 2, that I was able to calculate the expected death, and everything was in the expected parameter. And I want to say two more things. First of all, with a quote from my favorite person, W. Edward Deming, without data, you're just another person with an opinion. However, you need to set the data in relation to something, in that case, the population. And secondly, I want to say there's so many moving parts on the board that it's really difficult to calculate meaningful correlation between two figures. As I mentioned before, no one knows how many people are living in Germany. I hope that presentation was quite interesting for you. Again, I'm open for comments, suggestions, questions, and thanks again for listening.